Welcome back, everyone. And again, thank you all for spending an hour today talking about talking about this great project and learning from Greg. Greg is a designer and builder with over a decade of experience in custom residential design and construction as co-founder of Moontower Design Build in Austin, Texas. In 2021, he immersed himself in designing and building a prototype project called Cross Cabin, a plant-based home made of hemp, cork, and cross-laminated timber for himself and his family. Inspired by this experience, Greg established Cross Cabin Build and Supply to represent and distribute healthy, high performance, and low carbon building materials in Texas. He has a passion for building with natural plant-based materials rooted in the commitment of the AIA Architecture and Design Materials Pledge to support health at 3 scales: human, social, and ecosystem, and to prioritize climate impact and circular economy considerations with all material specifications. Thank you so much, Greg, for joining us today, and take it away.
All right, so this presentation is called Don't Judge a House by Its Cover. So I'm going to talk about this project, but I'll also cover kind of the storytelling approach and the research behind kind of moving in this plant-based natural building material direction. So storytelling is a big part of the theme here. So Cross Cabin Build and Supply, our mission is to bring the beauty of natural materials into architecture in Texas and beyond. And our kind of motto is feel nature at home. So Cross Cabin Build and Supply was founded in 2022, and we supply and promote natural, healthy building materials. And we're a sister company to Moontower Design Build, which was founded in 2009. And our mission with Moontower is we craft inspired, healthy homes in Austin for generations to come. And we do architecture and construction. So zooming out some, how do we tell new stories about how people can understand and value buildings? And a good story makes you laugh, makes you cry, lifts your spirits, and sparks curiosity about the world. So thinking about storytelling, I remember Goodnight Moon was my favorite book as a kid, and I used to ask my mom to read that book to me over and over again. And thinking about children's stories and how effective they are, kind of sharing a vision of the world and kind of sparking curiosity, I pulled a children's story from this book. From the Parsons Healthy Materials Lab, which is a fantastic organization that you guys should all follow and support. And in this book, there is an essay called Decarbonizing Materials and Climate by Charlotte McCurdy. And within this essay, I pulled a children's story. This children's story is called Ancient Sunlight by Charlotte McCurdy. I like to think about carbon in terms of sunlight. Until about 150 years ago, humans met their needs for light, heat, transport, food, and materials with the energy from the sun. But in the last 150 years, we've built a dependence on ancient sunlight. Fossil fuels are also the secondary energy of the sun, but much more delayed in time. And when we use fossil fuels, either by burning them for energy or extracting and manipulating them into useful molecules, we release that stored ancient sunlight and that stored ancient carbon. I became obsessed with the question of what it would feel like to live in a society that was back in a present tense relationship with the sun. We take fossil fuels out of the long-term carbon cycle and pump them into the short-term carbon cycle. The short-term carbon cycle is what all life lives within and what humans historically use to build our societies. The goal is not to literally decarbonize. The fact of the matter is that we are carbon, life is carbon. In fighting climate change, we need to decide how we use our carbon, which carbon, where we want to take it from, and where is a good place for it to go. So one of the big questions of this presentation is, where do buildings come from and why does it matter? So this is the project that I'm going to talk about today. And this question and driving people to think about, where does this building come from? Where does this material come from? What is this, what is this wall made from? Is a driving kind of force behind this this project. And so if you think about the story of a building, here's a kind of life cycle analysis diagram. It starts at raw material supply and production and goes all the way through end of life. But typically we're most focused on, the construction and operation part of this diagram or part of the story. And so what we're going to be focusing on today is kind of filling in these parts that I have kind of blanked out here. So where do buildings come from? Buildings come from nature's carbon library. And nature's carbon library has 3 branches: farms, forests, and mines. So farms move sky carbon into plant fiber and soil and seeds. And the carbon building block time frame here is less than a year. So materials like straw, hemp, this is kind of like the carbon checking account. So in 3 to 12 months, you have a useful raw material, a useful building block for something that you can make a home from. With forests move sky carbon into trees and soil and wood fiber. So this carbon building block time frame is 30 to 100 years. So this is more like the carbon savings account. So we've got wood fiber, cork. So in 30 to 100 years, you have a useful raw material that you can make a home from. Now mines move old mineral carbon, this kind of ancient sunlight, into commodities with a side of sky carbon. Significant energy is required to extract and process this mineral carbon, resulting in emissions. And this is kind of like the carbon buried treasure. So we've got concrete, steel, gypsum, foam, vinyls, plastics. And the carbon building block time frame here is hundreds of thousands, millions of years. So putting all of these ideas in one infographic, this is an infographic from a carbon, it's a field guide for designers, or a field manual for designers. I might be messing up that title, but you'll probably find it. So over here on the left, we have our plant-based materials, and then moving right, we have our mineral-based materials. And what this infographic is showing is where we're going in the Earth's crust to harvest or extract these materials, and then how that harvesting or extraction also represents a flow of carbon into the atmosphere of our planet. And the big idea here is that where building materials come from shapes a building's climate impact. So over here on the mineral-based side, starting over on the left, we've got bricks, and then we've got granite, and then we've got limestone for cement, we've got glass, and you can see we're going kind of further and further into the Earth's crust. And then as kind of a subcategory of mineral-based materials, we have our plastics. So these are things that are fossil, basically fossil fuel derivative, fossil fuel byproduct produced materials. And so we have things like PVC, LVT, latex paint, polyurethane, foams. So getting back to this children's story kind of idea, for a long time we had this farms, forests, and mines as well defined by the 3 little pig story of the straw house, the wood house, and the brick house. But the world that we live in now is really mostly in between forests, mines, and plastics, as represented by this vintage 70s Barbie A-frame. And so thinking about this as a context, with this project, the question I was asking is, what happens if I put embodied carbon and health impact of materials first when designing a house? So starting by considering what the baseline is in our market in Austin, in our home. So the material baseline for a typical home in Austin is something that looks a lot like this. And these houses have a concrete slab foundation, wood framing, spray foam insulation, fiber cement cladding, drywall, concrete, LVT flooring. These material sources are primarily mineral. And so thinking about kind of reimagining this, I was reminded of this book, Food Rules by Michael Pollan. And in this book, Michael Pollan lays out a kind of simple rule for eating in a way that is beneficial for your own health, but is also beneficial for the health of the ecosystem that you're a part of. So that rule is eat real food, not too much, mostly plants. So I thought about reframing this with respect to design and building. So what if it was build with real materials, not too many, mostly plants? And real as in not heavily processed. So veggies and wood, not Fritos and foam. Or in other words, no home Twinkies. So reframing this not too many, mostly plants approach, we looked at a foundation of a steel pile and beam, and then using cross-laminated timber to take care of our framing, wallboard, flooring, and a portion of our, smaller portion of our insulation. And then with wall insulation and cladding, we used cork. And then with roof insulation, hemp and wood fiber. So this is the mostly plants kind of wall assembly. So one of the beauties of this wall assembly is it's a 3-component wall assembly that sort of mimics the makeup of a tree. So we've got 2 inches of Amarine MD facade cork, providing R7 continuous on the exterior of the CLT panel. And then our self-adhered air and water barrier from VaproShield. And then 4 inches typically of kind of sustainably responsibly sourced softwood with our cross-laminated timber. And the cross-laminated timber is exposed to the inside and is providing our structure. And the cork is exposed to the outside and is providing our insulation as well as our final finish to the exterior. So here again is what the project looked like all finished, the mostly plants house. And here's some construction footage of the process. So starting with the steel frame foundation. And so the steel frame foundation minimized carbon with respect to, or in comparison to a concrete slab, and gave us a flat surface to start putting cross-laminated timber panels on top of. There's a cross-laminated timber showing up on site. And then us maneuvering those panels, the floor panels being 5.5 inches thick, the floor panels mostly being about 4 inches thick. And starting to put this together, we were able to apply some of the air and water barrier on site, and then tape the seams with wrap flashing to complete the air and water control layer. So here in this image, you can get an idea of all these materials were cut to fit together like a big piece of furniture. So we're sliding this curved or this panel with a curved window cut in it. How it all slides together. And then putting on the roof panels, The roof panels were the longest panels on the project, so some of them were about 23.5 feet long. So what's the actual difference in carbon impact between a typical and mostly plants approaches? So here, starting at the top, if we built the same project in terms of space and walls, but did it in a more typical way, or typical for Austin. So fiber cement cladding, spray foam, drywall on the interior, and that concrete slab. This is establishing our 100% embodied carbon impact using the beam calculator from Builders for Climate Action. And so here we've got 27,000 kilograms of carbon dioxide emitted. If we took that down to a pure and beam, but kept the spray foam, kept the fiber cement, that's going to knock things down to 64% of that 100% option, or that 100% kind of a baseline. If we move to our mostly plants approach, that takes it down to 26% of the embodied carbon impact of the typical slab on grade. And then if we include the biogenic carbon that's locked in the cross-laminated timber panels, that takes the carbon impact down to negative 72% of that original 100% baseline. So moving through some of these options quickly, you see with the baseline over here on the left, the slab on grade, that slab is the biggest part of your carbon impact. If you take the slab out and go to a pier and beam, then the concrete for the pier and beam is still the biggest part of the carbon impact. But then the exterior wall cladding and the walls start to catch up. And then if we compare the pier and beam to the mostly plants approach, the steel foundation reduces the carbon impact of the foundation a little bit further. And then we start to get some of the carbon storage from the cork insulation, wood fiber insulation, et cetera. And then if you include the carbon storage of the CLT, that's when it pushes things into a negative, carbon negative embodied, or an embodied carbon negative place. So talking a little bit more about some of these materials, this biogenic carbon storage with the cross-laminated timber is based on that carbon uptake during growth, shown here in the bottom right corner of this EPD. So thinking about cross-laminated timber, the pros of cross-laminated timber are it's a carbon storing, structural, and finished material. It replaces your structural framing and sheathing, can replace drywall, paint, and finish floors. And easy air sealing from panelization helps replace high carbon materials like high carbon toxic materials like spray foam. And the cons are there is a complexity of carbon accounting for virgin forest products, which I'm not going to talk much about here, but we could address that in the Q&A if people have questions. And it's new and different. The panelized approach requires a different design and construction process, and it requires careful optimization to be more cost competitive. So here's an image of a cross-laminated timber panel that has a major axis and a minor axis, kind of super plywood is sometimes called. It allows you to design the whole house like a large piece of furniture. Here are the shop drawings that we had for the house with the CLT manufacturer. All the splines and details are modeled. Here's what it looked like shortly after install. And touching on that, carbon storing, this carbon sequestration of a plant-based material, this is from a new carbon architecture. And this is showing when a tree grows, that growth represents net carbon storage. And that carbon storage is typically greater than the manufacturer and the transport of a final timber product like cross-laminated timber, as long as the it's from a sustainably managed forest. again, same idea here. Atmospheric carbon captured and stored in trees. We store that carbon for a longer period of time in a building and kind of insert this in the part of the typical carbon cycle for a tree. So other alternate materials that we used here, steel helical piles. So pros are fast, potentially single-day installation, recycled and recyclable material with steel. And then beyond that, the greatest opportunity for reducing embodied carbon after concrete is insulation. So going over the insulation materials that we used on this project. So Amarine cork insulation. Pros of cork insulation are it's a carbon negative, completely non-toxic material. And it's a unique cladding and insulation all in one. And the primary cons are that it's new and different. So why cork? Again, over here on the left, you can see the declare label, the ingredients. It's just bark of cork oak tree. That is it. Cork, when it ages, sort of looks like stone, but it insulates like foam at about R4 an inch. Cuts like wood, hydrophobic, carbon negative, zero toxins. So the story of cork kind of all starts here. They peel the cork bark off the tree every 9 years, starting at 25 years of a cork tree's life. And that peeling of the cork bark is something that's good for the cork's health and the cork tree's health. And typically a cork oak will have a cork harvest every 15 to 18 cork harvests over the course of its life. So then in the case of expanded cork or this amarine cork insulation, you take large cork granules and put them in a mold, and you heat that mold up with steam that's at 660 degrees, so it kind of heats up like popcorn, and then the natural sap suberin in the cork holds the panel together. So cork is actually the oldest insulation material in the US. It was originally marketed by Armstrong in the 20s. The patent was filed in New York in the 1890s. So here are probably some of the earliest continuous insulation details you're going to see from this Armstrong corkboard kind of building contractor's guide. There's a project in San Antonio using cork as a continuous insulation. And so people kind of ask, like, oh, why did we stop using cork? Well, cork insulation was used prior to the advent of materials like asbestos, fiberglass, and styrofoam, which all kind of came into the market, from the 30s to the 60s. So all mineral-based materials with toxicity concerns. Like there's a detail of some of the cork on the project. So then talking about some of the cavity insulation, I talked about the house as a big wood box, blanketed with kind of plant-based insulations like hemp, wood fiber, and cork. So hemp wool, it's a carbon negative insulation, US grown, non-toxic material. Hemp is a fast-growing, resilient rotation crop. It'll grow 8 feet tall in 3 months. And the cons are it's new and different. And alternate material, wood fiber insulation from Timber HP. Pros, it's carbon negative, US made, non-toxic material. It utilizes waste wood fiber. So waste wood fiber from cutting solid sawn lumber, like 2x4s, 2x10s. So this is a real kind of carbon impact benefit using waste wood fiber. And get all 3 types of insulation, loose fill, batten board. It's unique performance benefits related to the thermal kind of inertia, the thermal storage of the wood fiber. And the cons are it's new and different. So looking generally down here at the bottom with cork, hemp, straw bale, so these plant-based materials that provide carbon storage. Here's a graph showing the wood fiber kind of carbon footprint relative to fiberglass, mineral wool, spray foam. And so if you looked at a 2x6 wall comparison, if you did the same wall, same R value with all foam, over here on the left, you've got 7,300 kilograms of carbon dioxide. If you did it with all rock wool, it'd be 6,500 kilograms of carbon dioxide. If you did the same wall, same area, same R value with an all plant approach, in this case, wood fiber and cork insulation, it would be negative 5,728 kilograms of carbon dioxide from an embodied perspective. So here's some quick images of us installing the wood fiber and the hemp on the roof of the building, on top of the kind of cross-laminated timber roof structure. So beyond embodied carbon, natural plant-based building materials tell a legible, multi-sensory story about where buildings come from. So here's a video of the project.
I had no idea how I was actually going to feel in this space until we started, staying the night here and actually like living in the space. And it feels like no place I've ever been before. You feel a sense of calm pretty much immediately. That was like one of the biggest surprises about this project in the end, how it turned out, just the overall feel, how your body and your mind and it just relaxes you completely as soon as you walk in the doors and sit down. I'm Jackie Letellier.
I'm Greg Esparza. We founded Cross Cabin 3 years ago as a sister company to Moontower Design Build. And with Cross Cabin, we focus on natural building materials and natural buildings. It was kind of a combination of our passion. They're kind of sprung to a degree from our background. So Jackie's a chef. We met at a farmer's market in East Austin, and what kind of drew both of us to that community is a community about thinking, where does my food come from? Where does my food come from in nature? Who is making it? How is it grown? Cross Cabin, at its heart, is about kind of making legible where materials are coming from in nature. I was reading a book about what are options for insulation materials that you can use that are plant-based and carbon storing. And then when I found out more about the history of cork and looking at images of really beautiful projects that were using cork on the exterior, I really kind of fell in love with it as a material. It tells such an interesting story about where buildings come from. Like, where are we harvesting things in nature to make shelter? And beyond that, it has such unique qualities in terms of how it ages and weathers that mimic what tree bark does. We've got 4 inches of solid wood on the interior that's providing structure and an interior finish, doing a big part of like establishing the smell and the feel of the space on the interior. And then that's protected by 2 inches of 100% cork bark. And that 2 inches of cork is the thermal protection. It's what's keeping the house warm or keeping it cool. And then it's also protecting the house from extremes of the sun. The wood that we used upstairs is a Moffy natural wood floor. It's a larch volcano floor, and it provides this really beautiful kind of subtle texture underfoot, where you feel the grain of the wood, and it becomes something that helps you feel grounded, and helps you feel calm in the space. The way that we approached light in this design was the skylight. There's a stream of light that comes into the space, start your day and having this kind of concentrated experience of light. The view that way, since we are on the top of the hill, is just kind of a wall of trees, lots of different types of trees, like undergrowth trees, the taller like cedar elms. So that view, kind of unobstructed in terms of not having a rail or not having anything in front of it, was something that I really wanted to maintain. I think our mission and vision with Cross Cabin is rooted in having people reconsider how the act of making a home, how the act of making shelter can be something that provides a really tangible connection to nature. So here are some finished images of the house. So walking up, yeah, that cork bark just silvers and is constantly changing colors. So it's very, it mimics what happens in nature, but it's very atypical for a building material, when typically a building material, you're like, what color is this going to be? And then how do I maintain it to keep it this color? The cork is constantly subtly changing color. So then walking into the house, one of the first things that people say, and alluded to in some of the video, is like, man, this place smells really good. And that kind of gets to, and the reason it smells really good is the floor is only finished with a mouthy kind of linseed oil finish. We just clean it with a linseed oil soap. And then the cork, the wood are left unsealed on the walls and the ceiling. So the smell is a very big part of the experience of the house, and is this kind of powerful, direct kind of connection to nature. It's in line with the kind of principles of biophilic design. So there's a limited material palette throughout the house, using cork and wood in different forms. Here's kind of a view of the wall assembly on sort of in cross section, which is an interesting moment because typically we're not usually able to see like what a wall is made out of. The upper bedroom, the primary bedroom downstairs, primary bathroom, the cork shower in the mirror, and the middle bathroom. This is a rich light door, compressed paper, or a sort of laminated paper. A few more details. It's a sight glazed curved window. This door handle that was made from a kind of scrap from the stair. Scrap kind of cut off piece of 4x10. And a couple night views. And that's it. So thank you very much. My email and our Instagram at Cross Cabin are down at the bottom. And then we sell and represent a lot of the materials we were showing in the house. Some materials like the Amarine cork insulation, Mafi natural wood floors, Alchemist mineral paint, Timber HP wood fiber insulation, Carbon Smart wood, Vapor Shield, Simpson strong ties, mass timber, kind of a fastener kind of products. So thank you very much.
So Barbara in Oz, she's passionate about what she's doing down there, and it's got some installation questions. Barbara, fire away.
Sorry, couldn't find the unmute there for a second. Hi, so I had commissioned a prefabricated cross-laminated house, which was installed on my land in July. We're finally getting around to getting the cladding on, and it's the same cladding. It's the Amarin. Here we call it 5 centimeters. You call it 2 inches. And the people who sold it to us, Market Timbers in Victoria, said we should glue it onto the house. My building certifier, because they're completely unfamiliar with cork, said, you can't have cork as a cladding. You've got to put on fiber cement. So I said, fine, we'll have fiber cement, but the cork will be a decoration. So the whole house will be covered with cork. But we need to waterproof the fiber cement. We need a waterproof agent that's compatible with the adhesive that the cork people are telling me I should use. Did you use an adhesive to put your cork on your house? That's question 1. If so, which adhesive? And question 2, you made the window surrounds from cork. I would love to do that. How did you do that?
Thanks for the question, Barbara. Yeah, excited to hear about your cork CLT projects down under. There's not a whole lot of CLT cork projects out there.
No.
Yeah, so first question with kind of adhesive in general approach to installation. So we took that in our case, a 50 millimeter shiplap, and we screwed it to the wall with that self-adhered air and water barrier behind it, vapor permeable product. So this was Wrap Shield SA was the product we use. There's a lot of other comparable products as well. And so we did a kind of panhead screw through the bottom lap, and then you're actually able to take headless trim screws and go straight through the cork and bury it just a little bit past the face of the cork. And you don't have to plug the hole, it just sort of disappears. And then we were also able to use, within the Vapro Shield system, we used their Liquiflash as an adhesive in several different places, in spots where we didn't have, where we had small kind of in corners where we had those butt joints that were, showed up on the video and some of the pictures. In places where we wanted a little bit more kind of sticking or staying power, we used a Liquiflash, and that worked really well. So that's what we used in the shower as well. We just used Liquiflash and no screws. So
Okay. And the window surrounds.
yes, and the window surround. So the windows, the side glaze window surround. I mean, to be quick about it, and feel free to reach out to me by email. We could talk.
I will.
More
I can tell you.
Yeah, that side glazed window. So the insulated glass unit is an inch thick. So we created a plywood frame around it, and then a square plywood frame around it that was proud of that curved opening, and then stuck the glass in there, and then used the 2 inches. We kind of routed an inch cavity from that 2 inches of cork to put that to put around that. It was definitely an aesthetically driven detail. It has worked, it's pretty well protected by the overhang. It's worked well so far. On the interior, we did use cork as a trim for the interior, like where we had a lot of scrap. We had a lot of scrap 50 centimeter cork that we were able to just mill down and use as what, in place of what would typically be like a 1x wood trim. The nice thing about doing that is the cork, all of the seams where this 40-inch piece of cork stops, you can't tell where one piece starts and one piece, starts because of how well it blends, unless you're really looking for it. So, yeah, that's a kind of briefly touching on what we did with the windows.
So bottom line, you had a wooden frame around the windows and you covered the wooden frame with cork.
With that sight glaze detail, yes. With the other windows that were flanged windows, we brought the cork tight to the frame of the window. Sometimes we had to route to kind of allow for the depth of the flange on top of the, the face of the CLT. So yeah, the cork, because it's so easy to work with, so easy to kind of mill, it provides provides a lot of flexibility there once you get the hang of it.
Okay, because we have, sorry, my CLT panels were delivered to site with the Dorfner doors and windows already in them. So they came as a single unit. So the cork is going on top of all of that. So we're not, I think we've got a slightly different construction method. So I'll get back to you by email. Thank you.
Sure. Thanks, Barbara.
Great stuff, Barbara. And again, when you look at Greg's details, you see how they routed, you know, even like the sill detail and how they slope to the cork. It's great. Just
Yeah, I love it.
yeah.
I've seen his video on YouTube. I'm pretty
Well,
sure.
I even need to go back and see it because even from the last accelerator construction tech to this, just great stuff. And hopefully I'll be able to see it when I'm down there in Austin for Build Show Live in November. So Greg, we got to connect.
Yeah,
So
I was going to ask you about that. That would be great.
yeah, we'll talk about that. All right, Barb, we're gonna move over to Justin. Justin, I had a couple questions over to you, bud.
Hey, Greg, thank you. That was a great presentation. I was actually wondering, so the house, was it built on spec, or is that something that you're building for yourself as a kind of example project of everything that you're doing? And then follow up on that, if it is built on spec, was there any pushback from banks, realtors on like doing this, especially like how you sell it to people and everything?
Yeah, it was built for it was built for myself, or built for my family.
Mhm.
So that makes things easier with doing I mean, with dealing with like banks or, you know, appraisals, all of those sorts of things. I think it is easier, you know, like the check boxes for those sorts of forms are pretty not dumb, if for like a better word. Like there's not a lot of detail, so I would have just clicked or checked wood frame,
Mhm.
and it's a wood frame. It's close enough to a wood frame, I mean, but yeah, so I think the fact it did cross my mind, like kind of getting into this, like, okay, I think the fact that it is a wood system has some helps with its viability for something like if you were doing a spec home with it. We are working on kind of starting initially working on a spec home project with this system with Forgecraft in Austin, with also being that will be a passive house project as well. So but I think wood frame, you know, sticking with the, you know, kind of wood frame situation is the main that's the path that I would, you know, go with there. So.
Thank you.
Excellent. All right, Greg, hold on 1 second. We're gonna send it over to Kim to look at upcoming events.
Thank you, Sean. Starting off, we'd like to thank Stengel Engineering. They are our accelerator partner of the week, so thank you so much for your support. First up with our events and happenings, we have a new podcast episode 207. This is with James Ortega from FIAS, speaking about the Revive and Pro Forum event coming up in a few weeks in Providence. Next up for construction tech, we have a project coming next week. This is a passive modular case study, a recently certified FIAS project based out of Yonkers. This is a senior project, and the presentation will be all about navigating construction for multifamily modular projects. Next up on Friday next week, this has come really quickly, we have the Reimagine Buildings How to Decarb conference. This will be taking place from 11:30 in the morning Eastern until 5 p.m. We have AIA, PHI, and FIAS credits available for all hours, and we have speakers such as Lisa White, Chris Magwood, Lois Sereno, Carmel Pratt. You can see them all there. A great group of folks, and we hope to see you there. Link should be in the chat to register. Next up, as I mentioned, the FIAS Pro Forum is coming up October 21st in Providence. I know a lot of the accelerator folks will be there, so hopefully we'll connect with you in person. And we also have Building Energy New York City. This is put on by Nessie. This is taking place October 24th. I believe it's all in person in New York. And I'm going to hand off to Zach to speak a little bit more about conferences and another really exciting announcement.
Yeah, thank you, Kim. As Kim mentioned, on October 18th, so that's Friday of next week, we'll be doing the How to Decarb conference. And so we'll be covering building electrification, embodied carbon, operational carbon, existing buildings, affordable housing, equitable access, all those themes. So we hope you'll join us for that. And then also mark your calendar for Friday, December 6th, when we will be doing our next Reimagine Building conference that will dive into embodied carbon. So this is Reimagine Building's carbon storage. We're presenting this in collaboration with Chris Magwood of the Rocky Mountain Institute, and couldn't be more excited about this one as well. So this series of Reimagine Buildings conferences is turning out to be very exciting, and will extend into 2025 as well. So more news about that soon. Also, please check your inboxes over the next few days. We'll be announcing soon the opening of the Reimagine Buildings Collective. And this is our membership community where we bring together building professionals who want to step up and tackle climate change. And inside the community, we will have access to experts in residence doing Ask Me Anything sessions each week where you can get your answers to your burning questions. And Kim, let's move to the next slide. And we also have cohort-based courses that we'll be launching, beginning with a Zero to Hero course by Ed May that takes folks from the beginning skills around PHPP to being able to model a project for a paying client over a 10-week period. So that'll be launched early in November. And then free admission to Reimagine Buildings conferences will be available to members of the collective, exclusive access to our Reimagine Buildings podcast. But the most important thing is the connections we'll be making on the Reimagine Buildings Collective Forum. So this is a place, basically, we're building a community that will have your back as you tackle climate change with your buildings, and we hope you'll join us. So again, we'll have an announcement of the opening of that very soon. Thank you.
Great stuff, Zach and Kim. And yes, I got a sneak peek of the forum. It is so cool. I'm so excited for all of you to check it out. Liking what they're doing. It's pretty awesome. So we've got about a minute left in the first hour, but hold on. We're going to kind of wrap up the hour. We'll go to the final 15 because there's still lots of questions. So thank you for joining us. If you do need to leave, if you still got another 15 minutes, hang out. Greg will show more about the details and the fun things that occurred in his build and answers those questions. But if you do need to jump, again, you saw what's happening in upcoming, a lot of great events. So you can either catch us in either the magazine, the podcast, the lives, YouTube, all the fun areas you can continue on watching and participating with Passiv's Accelerator. But if you do need to go, enjoy the rest of your day. Otherwise, we are going to continue. And in the queue, bear with me here as I get that queued up. We go to Tim. Tim Spittler, if you're still with us, I think you had a couple of questions. Please pick one and we'll keep moving things along. Tim, you still with us?
Yeah, I'm still here.
Perfect.
I was enjoying the videos. I was curious if there would be a link in to the YouTube videos to see them, but maybe that got added to the chat.
We
Yeah.
will look it up. Sorry, go ahead, Greg.
The video the longer video that I showed, Instagram is gonna be the best place to follow for that, because that video actually just received the draft of that like this morning. So that hasn't been officially published, but it will probably be officially kind of like released in
That was the building one, like when it was being put together.
Oh, the building one is on. If you search Cross Cabin on YouTube, I will drop that link in there. Yeah,
Okay, cool. Yeah, that was when I was interested. It looked like a cool operation.
Yeah, I'll drop. Yeah, we have a YouTube channel, so I'll drop the link to that video in there right now.
Cool, thank you.
Yeah,
Great
it's
job.
always cool when Lego gets put together by adults, it's really fun. All right, Todd, over to you. Todd, are you still with us?
Looks
All
like
right, let me know if
he
you're
has gone.
okay. Greg, over to you. Sorry, George Love.
Hi, Greg. A great presentation. I was just curious where you sourced the graph that you had on one of your slides that showed the embodied carbon versus the sourcing of cross-laminated timber.
The which graph, like the one that kind of the what the like sort of life cycle cross-laminated timber where it kind of goes negative. That
Yeah, exactly.
that is in the timber chapter of the New Carbon Architecture book. The Bruce King and Chris Magwood New Carbon Architecture book.
Okay.
Yeah, there's great chapters covering mass timber in that book, New Carbon Architecture and Build Beyond Zero, and they really get into the complexity of like carbon accounting when it comes to timber products too. So those are great resources.
Yeah, I especially liked that dotted line showing, just if you source it from locally versus long distance, it makes such difference. Great visualization and great presentation. Thank you.
Thank you.
Thanks, George. Yeah, those are good books. Definitely get them, read them, and put them on your shelf. They're great resources. Ins, you had a question? Don't see. All right, we'll come back to Justin. So Justin, go ahead. Or Justin, do you have your questions asked? Okay,
No,
Justin,
my questions were answered. Thank you.
perfect. I know we had a couple times.
I just
We'll head over.
that YouTube link in the chat for yeah, that the YouTube link is now in the chat. So
Perfect. Great. Michelle, over to you. Oh, actually, no, Michelle had to run, so I will ask a question because she wanted it to, to come up into the things she was saying. Yeah, let's talk about HVAC. What did you have there for fresh air for heating and cooling?
yeah, so it's a 2-ton carrier VRF system from their VRF line. So there's a 4-inch kind of Aprilaire filter box on the bottom of that, and kind of an open return plenum sort of arrangement. The understair, kind of the understair area is also used as sort of an additional kind of mechanical space and a path to pull air into the return plenum from the kind of open area of the house. And that mechanical area has a 70 pint ultra air or 70 pint Santa Fe dehumidifier in there, that also has a kind of basic inch filter on it. And then underneath the house, there's a 100 CFM Panasonic ERV that is pulling constantly from the 2 bathrooms and then supplying to the bedroom and into that understair sort of return area. Other note about the mechanical is that there's only one kind of 12-inch circular to turbo nozzle, like that's conditioning or kind of supplying air to the whole open space, the loft, the kitchen, dining room area. And we have it set up so that we could add another register, but that one 12-inch register has been able to keep the thermal, once the house gets to a certain temperature, like it wants to stay at that temperature. So the mass of the wall and the continuous insulation have really helped to kind of keep it very very comfortable. So
yeah, can't wait to experience it. It's so cool, Greg. It's great. Again, all the pastel pencils are there, and it's simple when you've just got that big assembly that you've done that is, again, carbon friendly as can be. Love it. And again, I know I heard the last time, but just the whole farms, forests, and mines approach to building, so simple, so key, so it's great. Mo had a question. Mo, you still with us?
Yes, I am. Thank you.
Go ahead.
I'm more curious about the cork as a soundproofing material. How's that experience played with you, and if you actually installed it also with that purpose in mind?
yeah, I definitely knew that was going to be one of the benefits. irregularity of the cork surface, or the fact that there's kind of cavities and the softness of it. It's a thermal insulation, but then it's also an acoustic and anti-vibration insulation. So it works really well acoustically. There would be some testing information on amaremecorkinsulation.com. But yeah, experientially, the acoustic environment feels really nice in there. Folks who are more like musicians, or folks who are kind of more acoustically, minded, often comment on like, yeah, it feels like really dead in here, like in a acoustic, a positive acoustic sense. So yeah, people seem to like it. So
Thank you.
Awesome.
No problem.
Thanks, Will. Jessica, you're up next. And you're on mute, Jessica. There you go.
I wanted to ask if there's any window or door blinds or shading beyond the roof overhangs.
There's some basic, it's really only in the bedroom. There's some basic kind of linen curtain. And then outside of that, there are no window treatments.
Okay. What was the square footage in the bedroom bathroom spec?
Sure. It's 2 bedrooms, 2 baths. That upper bedroom is that loft, but there's 2 full baths, and square footage is 1,000 square feet. Interior conditioned, and then there's that large 12 by 18 screen porch.
Okay.
Great space. Thanks, Jessica. Inside a question about costs, Greg. So I guess as we wrap up, I mean, everyone always wants to know how much did it cost? What's that whole, how do you get past the cost of doing something different? How do you want to tackle the cost?
Yeah, right now, if we were to recreate the house, we would be expecting a cost of around $500,000, around $500 a square foot here in Austin. So that's not like with this project, it costs less, it costs less than that, but there are a lot of things that kind of skewed that with like 9 of the 10 windows we had left over from other jobs that we'd used, and over, so there's a lot of scrappiness with some of the other things. So but yeah, if we were to do it again, $500 a square foot.
Gotcha. And again, when you look at the quality and finishes of it, I mean, again, I don't know the average cost of Austin, but from what I've seen and can hear, I mean, that's pretty on par with standard construction, and even up here in Vancouver, I mean, that's on par. So it's great that great alternative for very similar costs. And again, we can always talk about the benefits, and what you've done is pretty awesome. That's great. Jean popped in here for a last question about Jean. Why don't you come on and ask a question?
I'm just wondering if there was any weather sealing, or would there be any weather sealing required on the cork in a moist climate?
Thanks, Gene. Yeah, there wouldn't be any weather sealing required with cork in a moist climate or a dry climate. The moisture content of cork will change a bit, from depending on if it's 80% relative humidity or like 10% relative humidity. But cork is not a porous, it looks porous, but it is not a porous material. It is a closed cell structure. It's effectively a natural foam. So it's if it's a moist climate, dry climate, really doesn't matter. You can seal it if you want the color to stay consistent. If you don't seal it, then it's 100% natural material that will continue. It'll silver, and then it will darken, and it'll continue changing colors. The other really cool thing about it, if you leave it natural, is that if you want to reset that process at any point, you can just sand it. Like if you sand it for 5 seconds, it goes back to that original color. Effectively the surface of the cork just kind of it sort of sunburns over time. It kind of gets but in a, it just sort of, it looks more and more like tree bark the older the house gets. So
Great stuff. Great. Just a question too. You know, excuse me. So excited about what I want to say that I choked on it. What does the neighbors think of, you know, the beauty of the house and what kind of like discussions you've had or comments from just that exterior because it's so different and
Yeah, neighbors, you know, that's a good question. Like, I don't, we have a, it's, I think somebody, the people like living directly across from it, like the house isn't occupied very, consistently, so we don't have like a
okay.
neighbor experience. But yeah, we've done a lot of tours. We did the local AIA tour, so we've had, and we do a lot of happy hours with, we did a happy hour with the Healthy Materials Lab when somebody was in town, and happy hour with, yeah, those kinds of things. Yeah, and then it's sort of all over the place in terms of how people feel about it. Some people really like it. Some folks are like, okay, this is cool, but it, like I said in the presentation, it's such a different mentality than you're used to with a building material, where typically it's like, hey, I'm going to look at a color sample and that is what the color is going to be, and I'm going to, what is the maintenance required to keep that color? It, you know, with cork, it's like, it, you know, the samples you get are, it's, the color is going to constantly change. And fundamentally that is how things work in nature. When you're absorbing damage factors of UV, heat, water, natural materials absorb and react to that damage by changing appearance. When like an artificial, you know, with an artificial approach, if you're looking at like a painted hardy or whatever, that idea is like, okay, we're going to try to resist nature and keep a permanent color. And that ultimately will always, you know, it's just a different, you know, it's just a different mindset. So
Thank you everyone for joining. Greg, thank you so much for taking us through your project and the process and giving us a peek inside your home, literally. So it was a great presentation. The questions were fantastic, and we'll see you next time.